Structural analysis. Statically determinate beams. In this lecture, we are going to answer two questions. What is a statically determinate beam, and how to analyze it? A beam is a properly supported structural member capable of carrying loads that are perpendicular to its longitudinal axis. Such a member is called a beam because the loads cause it to bend, like this. The analysis of such a beam involves calculating its support reactions. In this example, beam analysis entails calculating the three support reactions, AX, AY, and BY. Then, what is a statically determinate beam? A beam is called statically determinate if its unknown reactions can be calculated solely using the equilibrium equations. Now, how do we analyze such a beam? Before we can answer the question, let's review reaction forces associated with each type of support. The three most common support types are pin, roller, and fixed supports. There are two reaction forces associated with a pin support, a force in the x direction and one in the y direction. A roller support provides one reaction force only. Here, the force is perpendicular to the support surface. A fixed support has three reactions: a force in the x direction, a force in the y direction, and a bending moment about the z-axis. To clarify, let's look at two examples. Suppose our beam has a pin support and a roller support. Here, there are three reaction forces, two forces associated with the pin support, and one force associated with the roller support. In this example, the beam is fixed at one end, but free at the other end. Therefore, there are three reactions involved here: a force in the x direction, a force in the y direction, and a bending moment. In order to analyze a beam, it is customary to draw a diagram called the free body diagram, showing the applied and reaction forces and their locations in a Cartesian coordinate system. Note how each unknown force in the diagram has been uniquely labeled. The free body diagram helps with the correct formulation of the equilibrium equations. To determine the support reactions, that is, to analyze the beam, we use three equations. 1. Sum of the forces in the x direction must be 0. 2. Sum of the forces in the y direction must be 0. 3. Sum of the moments about the z-axis at, say, point A must be 0. The first equation in the expanded form gives us AX equals 0. The second equation gives us AY plus BY minus P equals 0. Third equation gives us P times L divided by 2 minus BY times L equals 0. Solving the third equation for BY gives us BY equals P divided by 2. Solving the second equation for AY gives AY equals P divided by 2. Before we end this session, let's look at two more examples. Here, we have a cantilever beam subjected to a uniformly distributed load. Let's analyze the beam. First, we draw the free body diagram for the beam. For the purpose of finding the support reactions, we can replace the uniformly distributed load with its equivalent concentrated load. Now we can write the equilibrium equations. AX equals 0. AY minus 20 equals 0. MA minus 20 times 5 equals 0. Solving the last equation for MA gives MA equals 100. From the second equation we get AY equals 20. And the first equation gives us AX equals 0. The second example is a beam with a pin support at the left end, a roller support at the right end, and another roller support at the middle of the beam. The beam is subjected to two concentrated loads. To analyze the beam, we start by drawing its free body diagram. Note that the diagram shows 4 unknown forces, 2 support reactions for the pin support, and 1 reaction for each of the roller supports. Here, the equilibrium equations are AX equals 0, AY plus BY plus CY minus 2 times P equals 0. 5 times P plus 15 times P minus 20 times CY minus 10 times BY equals 0. Notice that we have 4 unknowns but only 3 equations. Therefore, we cannot solve for the unknowns. The beam is not statically determinate. We will discuss techniques for analyzing statically indeterminate beams later in the course.